Geometry. Introduction. Geometry was used to measure earth. Today, it is used in the fields like art, building constructions, engineering, and designing. If we observe our surroundings, we find many things related to geometry. Buildings, houses, huts, books, tiffin boxes, playing balls, etc. are all related to geometry. History of mathematics. That Babylonians used geometry during the period 3000 BC to 2000 BC. Babylonians found formulae for area and perimeters of rectangle and square. But in 300 BC, geometry took a scientific shape with 1. Undefined and defined terms, 2. Axioms, 3. Theorems, and 4. Further definitions and deductions that were proposed by Euclid of Greece. From ancient Vedic times, geometry got special importance in our country. It was learnt only as a technical art required for yajnas and yagas in the very beginning. From the very beginning, geometry was developed as a science along with astronomy in our country. Kalpa is a part of Vedas. The geometrical laws had become the laws of Kalpa in yajnas and yagas. Geometry was developed as Syllabus sutras. Great people like Baudhayana, Apastamba, Katyayana, etc. became famous authors of such Syllabus sutras. Our country did considerable contribution to different fields of geometry and their properties. The relation of geometry with real life. Our house, our school, government and other office buildings are all of geometric shapes. Things used by people like round pencil, pen, scale, textbooks, notebooks, book bag, box, sitting benches, teacher's table, etc. all are related to geometry. We salute our national flag daily in our school assembly. That flag is in rectangular shape. Its pole is in cylindrical shape. Because of the existence of boundaries, the farmer is able to say that he possesses a certain area of land. It will be known from the study of history of mathematics that the subject geometry formed only because of the need to measure the land. Even many of talcum powder tins also have geometrical shapes. These are only some of the examples for the use of geometry in our day-to-day life. Geometry fundamentals. Geometry was developed with some basic concepts. Basic concepts like point, line and surface are the foundations for geometric shapes like triangles, quadrilaterals and different polygons. These things paved the way to the formation of three-dimensional objects. Angles and their different types help to visualize different forms of an object. Line, ray, line segment. Mark 2 points A and B on a plain white paper and join them with the help of a ruler and pencil. You get the adjoining figure. This line segment A, B is formed by joining the 2 points A and B. That means this has 2 endpoints. Observe the two adjacent figures. Betweenness of points. Look at the adjacent figure. Among the points A, B and C, if B is to be in between A and C, then AB and C must be on the same line in order. That means the sum of the lengths of AB bar and BC bar must be equal to the length of AC bar. For example, if AB bar is equal to 3 centimeters, BC bar is equal to 4 centimeters, then length of AC bar must be 7 centimeters. That means AB bar plus BC bar is equal to AC bar. Therefore, point B must be in between A and C. Such points are called collinear points. Therefore, points lying on the same line are called collinear points. In the adjacent figure, there are 5 points called A, B, C, D and E. A, D and B are collinear. So, D is in between A and B. But A, C and B are not collinear. Similarly, A, E and B are also not collinear. Why? Therefore, C and E are not in between A and B. AC bar plus CB bar not equal to AB bar, and AE bar plus EB bar not equal to AB bar. Closed and open figures. Some figures formed by curved lines intersect themselves. The curved lines that do not intersect themselves are called simple curved lines. Closed figure, interior and exterior. Every simple closed curved line divides a plane into 3 sets of points. They are 1. Set of points on the plane, closed curved line. Set of points in the interior of the plane, closed line. Set of points in the exterior of the plane, closed line. Angle. Angle is the union of two rays with a common endpoint. The amount of rotation performed by a ray with its endpoint fixed either in clockwise or anti-clockwise direction can also be called as angle. Angle interior. In the adjoining figure, the shaded region is called interior of the angle. Points P, Q and R belong to the interior of the angle. Angle exterior. The shaded region in the adjoining figure is called exterior of the angle. Points M, S, T and U belong to the exterior of the angle. Points B, X, O, W, A, Z belong to the angle. Triangle. The closed figure formed by 3 line segments is called a triangle. Parts of a triangle. A triangle ABC has 3 vertices, namely A, B and C. 1. A is the vertex opposite to side BC. Side BC is denoted by A. 2. B is the vertex opposite to side AC. Side AC is denoted by B. 3. C is the vertex opposite to side AB. Side AB is denoted by C. Exterior of triangle. Observe the triangle and some points in the adjoining figure. D, E and F are in the shaded region. In view of triangle ABC, the shaded region is called interior of triangle. W, X, Y, U and V are in non-shaded region. This is called exterior of the triangle. But the points A, B, C, G, H and T belong to neither the interior nor the exterior of the triangle. These belong to the triangle. Therefore, with reference to triangle ABC, we divide the points in the plane as 1. The points belonging to the interior of the triangle. 2. The points belonging to the exterior of the triangle. 3. The points belonging to the triangle. Altitude or height. The perpendicular drawn from any one of the vertices to its opposite side is called altitude or height. All altitudes of a triangle pass through the same point. Median. The line segment formed by joining any vertex of the triangle to the midpoint of its opposite side is called the median of the triangle. All the medians of a triangle pass through the same point. Quadrilateral. The closed figure formed by 4 line segments is called a quadrilateral. Interior of a quadrilateral. In the adjacent figure, the shaded region of quadrilateral PQRS is called interior of the quadrilateral. Points A, B, C and D belong to the interior of quadrilateral PQRS. Exterior of quadrilateral. Unshaded region in the adjacent figure is called exterior of quadrilateral. Convex polygon. If all the points belonging to the line segment joining any 2 points of interior of a polygon belong to the interior of the same polygon, such a polygon is called a convex polygon. Circle. A circle is the set of all points in a plane at a given distance from a given point in the plane. Circle parts. Center. We learnt that the set of all points in a plane at a given distance from a given point in the plane is a circle. In the adjoining figure, points A, B, C, D, E and F are on the circle. The point that is at equal distance from these points is O. If the length of OA bar is 7 centimeters, the lengths of OB bar, OC bar, OD bar, OE bar and OF bar are also 7 centimeters. This point O is called the center of the circle. Radius. The line segment joining the center and any point on the circle is called radius of that circle. An infinite number of radii can be drawn to a circle. Chord. The line segment obtained by joining any 2 points on the circle is called a chord. Diameter. The chord that passes through the center of a circle is called diameter. Arc. In the adjacent figure, a part of the circle is thickened. This part is called arc. This is denoted by AB arc. Minor arc. In the adjacent figure, the thickened arc of the circle is smaller than the remaining arc. Therefore, it is called minor arc. Major arc. In the adjacent figure, the arc other than the minor arc of a circle is called major arc. To denote the minor and major arcs of a circle, 2 points X, Y are marked on both the arcs. And then the minor arc is represented as AXB arc and major arc as AYB arc. Sector. Look at the adjoining figure. OA bar and OB bar are 2 radii of the circle. The union of minor arc AXB arc and radii OA bar and OB bar is called sector. Angle AOB is called angle of the sector. The shaded portion of the figure is the interior of the sector. AXB arc is also an arc. So OA bar, OB bar and AYB arc another sector. The sector with major arc is called major sector. And the sector with minor arc is called minor sector. Parts of a sector. Radius of circle becomes sector radius. In the adjacent figure, OA bar, OB bar are radii of sector. Angle AOB is sector angle. AXB arc is called arc of the sector. AYB arc is also an arc. So OA bar, OB bar and AYB arc forms a sector. Sector with major arc AYB arc is a major sector and minor arc AXB arc is called a minor sector. Semicircle. The closed figure formed when the endpoints of an arc of a circle and its center becomes collinear is called semicircle. Segment of a circle. AB bar is a chord of the circle with center O. If a paper of circular shape with chord AB bar drawn is cut along the chord AB, there forms two parts. Every part of it is called segment of the circle. Circle interior, exterior. A circle with center O is drawn. Shaded region of this circle is called interior of the circle. The region that is not shaded is called the exterior of the circle. Points P, Q, W, X, V and center O belong to the interior of the circle. Point F, K, T and U belong to the exterior of the circle. Points A, B, C, D and E belong to the circle. Any line segment joining two points in the interior of the circle belongs to the interior of the circle. Therefore, the interior of the circle is a convex set. Circumference of a circle. A is a point on the circle. By keeping one end of the string at A and placing the rest of the string along the curve of the circle to reach A, then the length of the string describes circumference of the circle. Circumference of the circle is denoted by the first letter of circumference, if that with C. Understanding of two-dimensional and three-dimensional shapes. Understanding of shapes. In our day-to-day life, we see houses, buildings, roads, thresholds, windows in our environment. If all these have specific shapes, we also find some objects formed by line segments and some by curved lines. Most of these are two-dimensional. Things in our homes like boxes, tins, almirahs, soap cakes, bricks, pillars all have specific shapes. These have length, breadth and thickness. These are called three-dimensional objects. Measuring the lengths of line segments. You might have already used the instruments box. Observe scale and divider. The edge of the scale is marked with 15 centimeters. Every centimeter is again subdivided into 10 millimeters. Let us see how to measure the length of a line segment using scale. Place the 0 symbol of the scale at A. Then read the number on the scale coinciding B of the line segment. This measurement shows the length of the line segment. Steps in measuring with divider. Place the pointer of one arm of the divider on A. 2. Place the pointer of another arm on B. 3. Without disturbing the position of arms, lift the divider and place it on the scale. See that the pointer of one arm is exactly on 0 on the scale. The number on which the second point of the arm shows is the length of the given line segment. By this process, we can measure the lengths of a line segments without parallax error with a divider. Measuring the angle. Protractor. Its curved edge is divided into 180 equal divisions. Every division is called a degree. It is denoted by 0. The divisions on the curved edge are at an interval of 10 degrees. These markings start at 0 on one end and ends with 180 on the other end. A line joining the degrees on either side passes through the center of the protractor. This line is called 0, 0 line. We need to know the measure of a given angle. The method will be as follows. Place the center M of the protractor coinciding with the vertex O of the angle. 2. Adjust the protractor such that The 0, 0 line of the protractor exactly coincides with the ray OA. Mark the angle between OA and OB on the edge of the protractor by measuring in anti-clockwise direction. 4. The measurement that is shown by OB on the edge of the protractor will be the angle measure of the given angle. We say the measure of angle AOB is 74 degrees, or simply we write angle AOB is equal to 74 degrees. Coplanar lines. The lines drawn in the same plane are called coplanar lines. Intersecting and non-intersecting lines. Mutually crossing lines in a plane are called intersection lines. The point where these intersect is called intersecting point. The lines of a plane that do not intersect are called parallel lines. If two lines are parallel to the same line, then they are also parallel to each other. Perpendicular lines. Take a paper and fold it as shown in the figure. Mark the points A and B on the folded line. Unfold the paper and fold the paper again by making B coincides with A. Now mark C and D on the second fold. The figure looks like as in figure 2. Mark the intersecting point of AB and CD as O. At O, four angles, angle COA, angle AOD, angle DOB and angle BOC are formed. Measure these angles. You will come to know that every angle measures 90 degrees. Each one of these angles is called right angle. In this context, AB bar L and CD bar M are called mutually perpendicular lines. If L, M are mutually perpendicular, we write it as L perpendicular to M and read it as L is perpendicular to M, perpendicular to M, perpendicular to M.